So according to, that means for understanding purpose only, I denoted some elements by circles. Each circle indicates the corresponding first non-zero element in the row. That is, the first non-zero element in a row is, according to myself, denoting by circles. And the arrow indicates the elements below that circles making zeros using row operations. Yesterday I told you these things, operations. So finally we got 3 non-zero rows. This is below the argument zeros, row echelon form. Now see the second problem. Let A is equal to, it is a square matrix. See, sometimes we look for the circled element, that is the first non-zero elements, as 1, -1 small elements if possible. Try to get small elements in the first non-zero element of each row, that is 1, -1, etc. Why? Because the next operation, next steps takes less time and feel comfortable also. Once you apply any operations, you may get, that means zeros, you have to get zeros in less time only. You feel comfortable also without any small mistakes. Okay. Now here see, almost all elements are more than 1 only. Okay. If you make with using this 2, if you make the lower element zeros using by first problem procedure row echelon form, then you may get large numbers other than these things also. That means your time increases also. You may get, that means you will get all, in that case you may get some mistakes and irritation also. That means if you get more numbers like that. Okay. In such cases you have to try to get +1, -1. So just if I apply R1 minus R2, 2 minus 3, so that here I can getting -1. Okay. So the first one is R1 minus R2. Now onwards I am applying this type of operations. That means these operations will affect on first position only. That's why in the previous problem I wrote that R1 implies, R2 implies like that. Now onwards I don't want to write like that, or it's your interest only. I want to write like this only. These operations indicate effect on first position. Effect on means this operation in the next step changes by first position only. Changes means here R1 first position. In the next matrix R1 changes to this operation. Okay. So -1, -1, -1, -1. R1 minus R2. Okay, put your fingers like that. Subtract 2 minus 3, 2. Where you put this answer? In the first position. What is first position? R1. In the next step R1 changes according to this operation. Remaining rows unchanged. That means same. 3, 4, 5, 6, 8, 9, 10, 11, 13, 14, 15, 16. Now start the circle. The first non-zero element is the first row. Make its exact lower elements zeros. That is, the arrow indicates the exact lower elements. Why? Because finally we reduce below the elements are 0. That is called row echelon form. So what are the operations? R2 with R1 operation, R3 with R1 operation, R4 with R1 operation. That means R2 plus 3R1. See, 3 plus 3 into -1 becomes 0. R3 plus 8R1, R4 plus 13R1. So these changes in the next step. First row same, because R2, R3, R4 only affect using these operations. 0, 1, 2, 3. Count this using this operation. That means calculate. 0, 1, 2, 3. 8R1, R3. 8 plus 8 into -1, 0. 9 plus 8 into -1, 1. 10 plus 8 into -1 is 2. 11 plus 8 into minus 1 is 3. Similarly, here also you will be getting 0, 1, 2, 3. Step 1, row 1 over. Come to second row. Where is the first non-zero element? This is second diagonal element. Itself is first non-zero element in the second row. Okay, and put the down arrow. Indicates the corresponding elements make to be 0. That means now in the next step, what are the operations to be done? R3 with R2, R4 with R2. I am showing the way here, the fingers. Okay, R3 minus R2 and R4 minus R2. This gives minus 1, minus 1, minus 1, minus 1, 0, 1, 2, 3, 0, 0, 0, 0, 0, 0, 0, 0. Now the last two rows zeros. That means the first condition, 0 rows if any, they belongs to last level of the matrix. So first condition echelon form satisfied. Second condition, go by circling the first non-zero element in each row. Now the number of zeros before this minus 1, 0 zeros, that is no zeros. The number of zeros before this circled element, 1 0. That means zeros increases or not. Finally you see, close the diagonal element, below the diagonal element are all zeros or not. That is called row echelon form. Okay, he is in row echelon form. So what is the procedure for finding rank after reducing it to row echelon form? Number of non-zero rows. That means number of circles. Each circle indicates the first non-zero element in a row. Therefore, rank A is equal to 2. So I have done two problems. One is for rectangular matrix rank, other is for square matrix. Using this method and the previous method for square matrices also, you can apply the previous method for rectangular matrix also. Okay. Next, I am giving you two more problems along with answer. Later you check it, correct or not. Find the rank of first problem. Zero, 1, 2. Minus 1, 0, minus 3, minus 2, 3, 0. Okay, or this also you can do, minus 1 plus 1, 1 minus 1, 2 minus 2, 0. Just 4 by 4 matrix. Okay, for this answer is rank of this matrix is equal to 4. Second problem, which is given 1998, 2 marks, 1487, 0, 0, 3, 0, 4, 2, 3, 1, 3, 12, 24, 2. Answer for this 3. One more problem is given. 1, minus 2, 3, 4. Minus 2, 4. Minus 1, minus 3. Minus 1, 2. 7, 6. Answer for this problem is 2. Just try later at home whenever you are free using any method, either rank definition method, original method, or row echelon form method. Now all of you, yesterday I already explained in the question and answer session, two to three students asked in determinant one of the properties, I have made a mistake, small word mistake. Okay, please modify that one of the properties. Yesterday I told you, if each element of a row slash, that is R column, in a determinant be multiplied by the same factor k, then the whole determinant, that means given determinant, that is whole determinant means the given determinant value, is also multiplied by that factor. Whole determinant means once a determinant value is obtained, that is called whole determinant. The value is also multiplied by that factor. Okay, I shown you yesterday already. 5 R1, I have applied one operation. Okay, please modify them. Next, one important point I am telling before approaching the second chapter. There are two types of equations: homogeneous, non-homogeneous. That means first of all you keep the equations, you write the given equations in standard form. Variables that are also called unknowns, that is going to solvable from the equations, keep that unknowns in the left side. If any other things, keep in right side. That is called standard form of the given equation before solving or solution of that problem. Okay, now here two examples I am giving. X minus y is equal to 1, 2x minus 3y is equal to minus 1. These two can be written in the matrix form as Ax is equal to B. What is A? It is the coefficients of all unknowns from all the equations. That is 1, minus 1, x coefficient, y coefficient, including symbol. In the second row, second equation, 2, minus 3. What is x? Which is a column matrix containing all variables or unknowns of the equation. That is x and y. What is B? It is the values in the RHS of the given equations. Okay, 1, minus 1. Okay. Similarly, x plus y is equal to 0. X minus y is equal to 0. Okay. These are Standard form, all unknowns belongs to left side, others means zeros on the right side. Whenever at least one element is non-zero on the right side, that is called Ax is equal to B, non-homogeneous equations. Whenever all the right side zeros, then it is called homogeneous equations, after keeping unknowns in the left side only. Can be written in the matrix notation form as Ax is equal to O, because right side all zeros, where A is equal to coefficients of all variables in the equations 1, 1, 1, minus 1. X is a column matrix containing all variables. O is a column matrix containing zeros. This is true for any number of equations with unknowns. Less number of equations, more unknowns. Number of equations is equal to number of unknowns in some problems. More equations, less unknowns. There are three types of problem solving before solving these problems. Okay. Now these are non-homogeneous equations example. These are homogeneous equations example. Both you have to put in the matrix form. Okay. Now I am giving the procedure to solve these things. Okay. Next. The unknowns are variables not only denoted by original letters, alphabetical letters X, Y, Z, etc. Sometimes X1, X2, X3. Sometimes A, B, C. Sometimes alpha, beta, gamma. Sometimes Y1, Y2, Y3. Unknowns are denoted by like that. But 99% problems denoted by X, Y, Z, X1, X2, X3, etc. like that. Okay. Now I am giving the procedure for solving both chapters, both subtopics in the second chapter. Subtopics means one is non-homogeneous equation, other is homogeneous equations. System of simultaneous linear equations simply can be written as linear equations. It is of two types. One, Ax is equal to B, which I already shown you in the previous example. This is called, the name of this notation is non-homogeneous equation. That is, at least one right side of the given equation is non-zero. EQS stands for equations. 2. Ax is equal to O. That is homogeneous equations. Okay. Where A is nothing but it is a coefficient matrix collecting all coefficients of the variables of the equation that are present in the left side. X is a column matrix containing all variables or unknowns of the given equations. Right side B, O is nothing but right side of the given equations after keeping in standard form. Okay. Now, a system, that means system means problem containing only one equation or two equations or any number of equations, that is called system of equations. Linearity means the degree of each unknown is 1. Okay. No products also. A system is said to be consistent, if it has a solution. Solution means two types. Single, other name is unique solution. SOL stands for solution. Second type solution is infinitely many solutions. Two types of solutions: unique solution, infinitely many solutions. That means whoever it may be, whatever the method you apply solving these equations, solution is always one unique solution, only one answer. Otherwise, if a solution second type of solution exists, means many answers. So finally your solution is correct or not. What is the verification? That is the basic procedure. Substitute all xyz variables of the given equations after getting the answer in the left sides. You have to get the correspondingly respectively one by one RHS. Then only that is called solution. If one equation does not satisfying your xyz answer, then it is not a solution. It's your mistake. Okay. A system is said to be inconsistent if it has no solution. That is, solution does not exist. Okay. Just I will show you one example. X plus y is equal to 1. X plus y is equal to 0. Two different RHS but same left side I have given. It doesn't mean that directly every problem like this. If you solve this problem, you will not get x value, y values. Why? Because x is one answer, y is one other answer. Sum of the two numbers either gives 1 or 0 according to this example consideration. Sum of two numbers is always a single number, is always a single answer. But I have given left side sum of x and y, which is same left side, right side is different. For understanding purpose only I am considering this solution does not exist, inconsistent. So here no xy value satisfying at a time both equations, because sum of two numbers never be at a time 1 and 0, either 1 or 0. That's why. Okay. Now I am giving the procedure for solving Ax is equal to b and Ax is equal to O using ranks. That is after reducing into row echelon form. I told you already yesterday and today beginning session also, the next chapter, the rank is entirely useful. Okay, throughout that system of linear equations, second chapter. Okay. So rank of a matrix plays an important role in the matrix algebra. Solving Ax is equal to b. Procedure I am giving step by step. Step 1. Form the C matrix, which is the combined matrices of A and B. That is, keep both left side coefficients and right side values of the equations in a matrix C by showing a symbol, understanding purpose. So that symbol here I shown that a vertical line are called slash. In some textbooks it is given the symbol is ratio, A is to B. For understanding B purpose only. Left to this symbol is A matrix, right to that symbol is B matrix. Okay. I will show you in the problems. This is called the augmented matrix, which we have studied in +1 level 11th standard for Gauss-Jordan method procedure solving equations. Augmented matrix. Generally this is in the form of, see, A is a m cross n matrix, that is m equations n columns, m equations n unknowns, a11 a12 so on a1n slash a21 a22 so on a2n so on am1 am2 amn. What are these elements left to this line? That is the coefficients of all the given equations in the left side, mn elements. Okay, in this side, right side, b1 b2 so on bm. That is, this m stands for number of equations, n stands for number of unknowns or variables of the equations. Okay, this is the matrix. Step 2. If okay, before this I forgot to write a sentence on this C matrix. Reduce the matrix C into row echelon form, comma, which will help us. Okay, first let me complete all the steps, then I will come back again one by one step to explain. Okay, will help us to find the rank of A. Step 2. If rank A not equal to rank C, comma, then the system Ax is equal to B is inconsistent. That is, no solution. Solution does not exist. 3. If rank A is equal to rank C, then the system is given equations. Ax is equal to B, matrix form of the given equations, is consistent. That means consistent means has a solution. Solution means two types, I already explained. If rank A is equal to rank C, that means not required to write fourth point. Solution means all these points come under the third point only. Is equal to n. N stands for number of unknowns or variables. This is also called variables. Then the system Ax is equal to B has unique solution. If rank A is equal to rank C is equal to some number r less than n. N stands for again number of unknowns. Then the system Ax is equal to B has infinitely many solutions. In this case, comma, n minus r unknowns to be taken arbitrarily. And here you write by putting a solution variables, that is unknowns, putting by star symbol, got by backward substitution. Now I am going to explain. Now see, once you write this C matrix, first step, reduce this matrix into row echelon form. I shown you 2 to 3 problems earlier before in the rank of the matrix problems. Okay. Why? Because A is a part of C. Not required to find A matrix rank and C matrix rank. Throughout this chapter depends on rank of the matrix procedures only. That means reducing into row echelon form. Okay. So because A is contained in C, just reduce this C matrix into row echelon form. You will be getting A matrix before this margin, that is A matrix gives rank, and immediately simultaneously the whole matrix C also gives the rank, gets the rank. Okay. Now see, first point here, second point. After reducing the given C matrix into reduced row echelon form, that is not given C, augmented matrix. It is a combination of A and B, combined matrix of A and B. If rank A not equal to rank C, that means before this line that gives A matrix rank, and the C is itself whole matrix, both ranks unequal, then the system is inconsistent. That is, the given equations have no solution in the case of rank A not equal to rank C. I will show you in the problems. Next, if rank A is equal to rank C, then the system, the given equations are consistent. That means solution exists. So solution means 2 types. That's why after this 2 points are given. If both ranks equal to n, what is n stands for here? Number of unknowns. In the previous chapter, n stands for order of the matrix. Okay. Now number of variables are number of unknowns. Whenever both ranks, what are both ranks? A matrix and C matrix. Okay. A is a part of C matrix. Both ranks equal to n number of unknowns. Then the equations have unique solution. That is single solution. If rank A is equal, both ranks equal to some number less than the number of unknowns. This point tells that both ranks equal number of unknowns. This point tells that both ranks less than number of unknowns, and both ranks equal. Okay. Then the system has many solutions, infinitely many solutions. So to find that infinitely many solution, the procedure is, one point here I given down. In this case, n minus r unknowns to be taken arbitrarily. N is the number of unknowns, R is the rank of the both matrices. The difference is the number of unknowns to be taken arbitrarily. That means, suppose your rank is 3, number of unknowns 4. 4 minus 3, how much? 1. So from the given 4 unknowns, you take any one unknown arbitrarily. Arbitrarily means don't take a fixed number. Assign some arbitrary letter, any alphabetical letter. Okay, some K, some A, some B. Remaining all variables got by this. What you have taken one of these unknowns arbitrarily. That remaining unknowns, that means all unknowns after getting, that is called solution. That solution variables, that is a given unknowns, got by backward substitution. This star tells that once you reduce this C into row echelon form, okay, if that equations have a solution according to these points, then that solution is obtained by backward substitution. What is backward substitution? So reduce your last C step into row echelon form. Okay, first of all, then change that matrix into again C. Once again I am explaining. Once you reduce this C into row echelon form, and if you decided that the solution, then how to find the solution? Convert that last matrix C into equations again. This is the matrix converted already equations into matrix form. This is the matrix which is obtained by the given equation. Similarly, the last step convert into equations that belongs to triangular form, upper triangular form. That means your last step equations is always below the diagonal zeros. That is called row echelon form. So then that one by one variable unknown is got by backward substitution. What is backward substitution? Getting one by one xyz values from last to first. First to last is forward substitution, last to first is backward substitution. Okay. Now I am giving some problems. So this is the problem, GATE 2005, 2 marks, 1. The equations 2x1 minus x2 plus 3x3 is equal to 1, comma 3x1 minus 2x2 plus 5x3 is equal to 2, comma minus x1 minus 4x2 plus x3 is equal to 3. Have option A, no solution. Option B, a unique solution. Option C, an infinite number of solutions. Option D, 5 solutions. So in the above, I didn't give 2 solutions, 3 solutions, 5 solutions. Automatically option D is wrong statement. Okay, you have to check one of the ABC options. So first of all, you check whether it is standard form or not. All unknowns here, the 3 variables x1, x2, x3 are unknowns which are going to solve. They are all belongs to left side in all the equations. Remaining numbers on the right side. Since the number is non-zero, one right side is not equal to 0, then the given equations are called Ax is equal to B, non-homogeneous equations. Okay. Sometimes for confusion purpose, all the numbers belongs to left side and automatically right side given in 0. Don't confuse. Okay, bring that left side whatever the numbers present in the given itself problem into the right side, then only it is called standard form of the equations. So your first step, C matrix is combined matrices of A and B. So what is A here? Collecting all the x1, x2, x3 quotients in row wise in 1 by 1 equation and then put these values in row wise. 2 minus 1 3, 3 minus 2 5, minus 1 minus 4 1. This is the symbol indicates left to that A matrix, right to that right side of the equation, that is B matrix. 1 2 minus 3. Circle. Now problem reducing into row echelon form. R2 with R1 operation, R3 with R1 operation. That means 2R2 minus 3R1, 2R3 plus R1. This changes to the matrix. Using these operations, the matrix changes to. That means just whichever the element you are making 0, with the help of the circle element, take the LCM. After finding the LCM, in the 2 places you should get that LCM number. That means in such a way you multiply that number and then subtracting or adding depending on the situation. Okay, 2 minus 1 3 1 0. This becomes minus 4 plus 3 minus 1, 10 minus 9 plus 1, 2 into 2 4 minus 3 plus 1. Next, this becomes 0, minus 8 minus 1 minus 9, 2 into 1 plus 3 5, and 2 into 3 6 plus 1 7. The next step, second row, go to the first non-zero element, circle, immediately put the arrow. That means we have to make R3 element 0 with the help of R2. So what is the operation here? R3 minus 9R2. This simplifies to the matrix 2 minus 1 3 1 0 minus 1. Where do you put this operation in R3? First only effects. 1 1 0 0, 5 minus 9 minus 4, 7 minus 9 minus 2. Now this is the last step, that is we got row echelon form. See now. Closing the last column indicates the rank of the A matrix. This is the rank matrix, rank of the A matrix. Open this, this is the entire C matrix giving rank. Now close the last column. What is the rank of this matrix? Below the rank is 0. Row echelon form. Rank is equal to 3. Open. Still it has 3 circles. Row echelon form. So both ranks equal to. Therefore rank A is equal to rank C is equal to 3. Number of unknowns x1, x2, x3. So this is nothing but n. N stands for number of unknowns. Therefore, the given equations have unique solution. So put the tick for option B. So next I will show how to find the solution. But by the given question requirement, it is this step is over. It is over. Okay.